Yeah, we've got, what do we have so far?
What are you doing, my boy?
Being strange. He's good at that one. Watch me, I'm good at strange.
You're like that cat.
Here's what we have so far. Darwin, cancer biology, bacteria and food. You don't know if that's gonna be yours? Devils, walking stick tree. That's an interesting thing. Evolution immune system. Yours is three to five. Yeah. You don't have enough on it? Yeah. Shannon's doing embryonic diapause, which is what I mentioned last week when I said kangaroos can suspend gestational development of their embryos and then start it up again whenever they feel like it. And Anthony's doing selective breeding in dogs, which is cool because you could, name a couple different breeds and get a lot of good information on that. All right, let me pass these out.
I sent you an email.
Oh, did you?
Yeah.
When'd you send it? Today? Yesterday?
I sent it Sunday.
Sunday? I'll have to look. I don't think I saw it. Of course, like I said, here, call up you and Michael, this is you.
Mine's on the table.
Oh, I just threw your grades down. All right, you're gonna have to quit because you're gonna make me sick. I get motion sickness and you're gonna make me sick just looking at you. Here you go.
It's funny.
Hey, we're the only ones that get the layer and spread.
I know when I looked at the little most many things, I was surprised about that one.
Yeah, Darcy kept telling it was some sort of weird thing off like here on the pig.
Yeah. I realized I made a camp.
Okay, y'all, let me tell you what I did last week because it was inexcusable according to my family. So I put all the pigs outside in the back and it started to rain. So then I went out and grabbed them and I dragged them all out into the garage. And I thought, well, I'll just grade them here in the garage. That's not such a bad idea. So then I came in to cook dinner and I didn't even think about it, but I had a ham that I was planning to cook. I mean, it was already like, it was in the fridge and it was thawed and I got ready to stick it in the oven and Drew comes by and he's like, what are you making for dinner? And I said, ham. And he said, oh, Mom. And I was like, what? I didn't even, and then really honestly didn't even notice it. And then I felt terrible. I was like, I'm sorry. I didn't mean it that way. It was hilarious. They were not happy with me. I thought it was kind of funny. I thought it was kind of funny, but my family did not think it was quite so funny. Why did that not go? Come on. Hello. Why are you not doing it?
That was only like 70%.
There we go. Dokey. So are we at 12 yet? Oh, not yet. I'm giving Shannon a minute or two to log in. Uh-oh. Sisters. Oh God, no, I'm not gonna tell you this one. When your parents get old and strange things happen. Oh.
I'll remember. I was about to just, you should I just test it, right? I really think, oh. This is an earth bender. Avatar confirmed. Illuminati confirmed. Changed out the microscope. So I'm not joining over here. If I didn't join last week, I'm not joining this week.
Join in the cult.
James, join in the cult.
Okay, he need a pillow to do it.
Why is normal activity become a cult? This is just a thing some people do with the cult. Just having water on your lap.
Like for joy, because
See, even she denies the cult.
We're making a cult of time or shoe.
We are, yeah, acolytes. We're going to acolytes.
You're encouraging him, and that's not okay. What? You're encouraging him. You're like, I played football for 10 years. I don't get concussions anymore.
Tom Brady.
It's very much done, huh?
Tom Brady's like, yeah, I spent time.
Alex, please. Thank you.
Tom Brady was like, yeah, my wife and kids are nice, but I'd rather go back to being hit by big sweaty men. Pays more. No, you just said truth. They added to it. Therefore, not figures.
In a couple of years, we found out that Tom Brady really wanted to stay home. Mrs. Brady just couldn't handle it. He was coming back. Oh,
Just know, like, no.
He kept like putting bleach in the wrong thing.
Not messing up the laundry and stuff.
He's like, look how well I can cook. He's like, I'm taking cooking classes.
This is more about Brady.
He slept in past breakfast too many times. Go back.
Forgot to take kids to school.
Yeah. No way those kids go to school, right?
Private school.
I do not want to go near that.
How old are his kids, you know?
I think they're around our age.
Okay, let's go. Let's do our thing. Let's get started. Shannon will ding in at some point. I was waiting until noon for her, but she'll come along. So we are moving into our last lesson of Unit 7. And then you have your test this week, right? So this is our animal behavior unit. So this was your homework. And the way this kind of has to work is if you commented on it or added to it or something, you'll get the credit for it. But since it's due today and it's the end of the quarter, if you didn't, then you just won't get credit for this homework assignment. So here were your answers, and I'll put that up where you guys can see it so you can check afterwards. I'll post it. All right, so we're moving on to behavior and evolution, animal behavior, all these fun things. So we did a yes. So do you know what it is? What kind?
it looks like a gecko.
Not a gecko. That's an anole. That's an anole. That's a green anole. That's what we actually had in the tank a couple weeks ago. They're native here. They're not always quite this green. It depends on the temperature and what they're against, because they do have some range of color change that's normal for them. And this, do you know what this is called? This is called a dewlap, and it's really prominent in the males, and they will flash it out like that to either to threaten other males or to attract females. I was sitting where Ethan's sitting one day, and I was doing some work, and I kept seeing pink out of the corner of my eye out there, and I knew pink didn't belong. And there was one of these guys on my rail, and it was summer, so all the leaves were up, so I didn't really notice the green. I just kept seeing this flash of pink, and he was sitting out there bobbing his head up and down, like, you know how they do? Like, hey, look at me, puffing it out and puffing it out and puffing it out. But it's really bright. The color is really bright, so it's really obvious. And if it attracted me, I'm sure he was either scaring away other dudes or attracting some ladies, whatever his intent was at the time. So behavior is the way an organism reacts to stimuli in its environment. So behaviors essential to survival and reproduction include fighting and catching food, selecting a habitat, avoiding predators, and finding a mate. Some behaviors can be influenced by genes and inherited. Certain behaviors evolve under the influence of natural selection, because obviously if the behavior increases an animal's fitness in its environment and it's influenced by genes, you're going to see that adaptation increase throughout generations. So stimuli is plural, right? For what's
Stimulus.
Stimulus. Good. Okay, good. Everybody knows that one. Nobody's going to get confused. All right. So we have learned behavior. And we have different types of learned behavior. We have habituation, classical conditioning, insight learning, and imprinting. Have you heard of any of these before? Yeah? Which ones are you familiar with prior to the lesson? Imprinting. What's imprinting?
Kind of like,
You're on the right, yeah,
Supposed to be
Following
a
it,
G with
like-
classical condition.
following, yeah. So what?
Supposed to be a G with classical condition.
Yes, there is. You caught it. Good job. I didn't even catch it. All right. And then habituation, James said, and that's when you're, how's that one go? Do you know? Can you describe it?
It's like a habit, right?
It's sort of, yeah, it's like getting used to something. It becomes part of your habit. You see it. So here's an example of habituation. So there's a truck there, right? Do you suppose those lions were that chill the first time the truck passed by them? I really doubt they were. These lions are out in the savannah. They're chilling out. They're all relaxed. I don't believe that truck passing by the first time got that response. So habituation is the process by which an animal decreases or stops its response to repetitive stimulus that neither rewards nor harms the animal. So we tend to put Ozzy in the crate when people are coming in the door. That's because when that doorbell rings, he gets really defensive. But if you put him in or even not, you don't have to ring the bell, you just have to open the door. So he gets used to people coming in and then we can let him out. Hopefully he'll just get used to it one day and we won't have to keep putting him in the crate. But yesterday someone dared ring our doorbell to leave a package and you would have thought like World War III had begun because the dog lost his mind. I mean, So here's a little video with habituation. Now, these horses have never seen a balloon before. And so their handler has put a balloon in their paddock with them and they don't know what it is. They don't know if it's dangerous or not dangerous. So you can watch them check it out and notice what she says. She talks kind of quietly, but I'll try to get the volume where you can hear it. But she talks about the older horses versus the younger horses and how they're all responding here. Let's see if I can get it where you can hear it. She's quiet.
Which is why you should never let a balloon fly up into the sky because what goes up must come down. After a minute, I realised that it was risky to let the horses explore the balloon while it was on the floor, because if one of them pulls it with their front legs and it pops, then they will feel fearful towards balloons. Whereas the idea is that they habituate to the balloon and they see that they don't need to respond to it and they just want to ignore it. So you see, after a minute, I stopped the video, I picked the balloon up.
See him shaking his head at it because he's not quite sure.
But this is not a good idea. But I put this video up anyway because it's interesting to see how the horses react to it. So the older horses Sky and Bart approach the balloon first, and then the younger ones wait to come over after the older ones and said that it's not so risky. Doesn't leave more and more time. But then Luca, who's one of the youngest, stays to have a look because he's not quite sure yet.
So it's interesting that they let the older ones go over first and check it out, right? They weren't those younger ones weren't quite comfortable going first, but they all habituated to it. It took a little time, but they all realized that it wasn't something that was going to hurt them and it wasn't something that was going to benefit them. It was just there. So they just ignored it, moved on. You guys have habituated to all sorts of things and you do it with sleep too. Think about it. Like if you stay in a hotel that has a train that goes by, it might wake you up the first or second night that you're there, first or second time that night. And after that, it just becomes part of the environment. You do it with all kinds of things. We all do it. So classical conditioning, this is probably the more familiar kind of like conditioning to learn sort of thing. So this is when a certain stimulus comes to produce a particular response, usually through an association with a positive or a negative experience. So this is very often what we use to train our animals, right? Like you tell them, sit, there's your stimulus, they sit, that's their response, and you reward them, and then they get a positive experience. So yes, if you're in psych or ever taken a psych class, you'll hear about this. So Pat, go ahead.
I thought classical conditioning was going to listen to Beethoven.
There's that too. Yeah, there you go. This is a fabulous example. And those of you who have siblings that are not in this class, you can try this out at home because this is really good. But this has to do with Pavlov. So Pavlov was the guy who had the dog and he would ring the bell and feed the dog, right? Ring the bell, feed the dog. And the dog learned to associate the bell ringing sound with food coming. So then Pavlov would ring the bell and the dog would come to him and he'd be salivating, like he's ready to eat, but there's no food because he's associated that sound with the food. So this is a perfect example of a Pavlovian experiment. And seriously, it would be fun to try on a real person like this guy does.
What's up, guys? My name
This is similar.
Today we'll be conducting Heisenberg tablet experiment with classical conditioning. So today.
Very
I'm gonna be
similar to the
conditioning
Office
my
one.
older brother James, and hopefully by the end of the experiment, he'll flinch in response to an alert sound on my cell phone. In classical conditioning, the unconditioned stimulus causes an unconditioned response. And a neutral stimulus is paired with the unconditioned stimulus. Then the neutral stimulus alone causes a response. Initially, I'll use an alert sound from my phone as a neutral stimulus to get an unconditioned response. Then for the next few trials, I'll use this unconditioned stimulus of the ball hitting my brother to get an unconditioned response. Next in the experiment, I'll attempt to make the neutral stimulus of the alert sound from my phone to get the exact same reaction as the paper ball being thrown at my brother through classical conditioning. After each alert sound, I will throw one paper ball at my brother. Let's have a look.
I love the looks. The shade is great.
You want attention?
You want attention?
Try to get attention. You're gonna try to get somebody in there.
It's great. Yeah, he's escalating for sure.
Did you see that?
Did you see that? I don't think that's the reaction you want.
That's great.
But if you hear the alert,
It's fabulous. He made it work. It was just great. Yes, there is that one on The Office too. That's, yeah. Have you seen that one? Cole, you want to describe how that one goes, or Michael?
Oh, yeah, he turns
Ethan.
on his computer, so it makes the Windows sound,
Yeah.
and every time he does that, he offers Dwight a mint. And Alfred. He
Yep.
gives it to him every time, and then one day, he hits the button, and then Dwight just does this.
Sticks his hand out.
What are you doing? He's like, nothing, sorry, my mouth.
Yeah, he looks so confused. What happened? So operant conditioning. Now, this is the one that you're probably most used to if you have, kids or dogs or anybody you're trying to train in your house, right? So this is a trial and error learning, and this is reward and punishment. So you teach an animal to behave a certain way through a repeated practice. Like with dogs, sit, here's your treat, sit, here's your treat. So operant conditioning is it's a type of classical conditioning. It kind of falls under that umbrella. This is a great example of operant conditioning. You want something from somebody? Tell them what you'll give them. That was a good one.
Like if you score one basketball shot, you get one candy, okay? Go on. Here.
The look on his face. Yes, I got the candy.
Like if you score
I like that one. So insight learning. Insight learning is a little different. Insight learning is when you take what you already know and apply it to a new situation. You take something you previously learned in a new context and then go ahead and apply it. This is the kind of thing that increases with age and experience too. You'll know. Drew, is that yours? Oh, it's Jason. Great. Sorry, I am conditioned to think it's Drew. That microwave beeps, I think it's Drew making soup, because it always is. So anyway, insight learning, you take something you've already learned and apply it to a new situation. So do you ever watch the Brain Games show that they have on Netflix sometimes? Well, there was one where they had like a bunch of light bulbs hanging from chains in a room, and they would bring somebody into the room when it was dark, and then they'd say something like, turn on another set of lights. It was something like one of these light bulbs was on before you came in, or one of these light bulbs was off and the rest were on. Go ahead and you have 30 seconds to tell me which one it is. And it was the older people who got it because they would touch them all.
Yeah.
And the younger people would sit there and think I don't know how to figure that out. Like, they never thought to touch them.
That's what I would.
Right, well, so,
Yeah,
yeah,
I just thought-
you have some experience in life, right? Yeah. So it takes experience to learn this stuff. Now, crows, this is a crow. Crows are actually really smart critters. They're really, really smart. And they've done a lot of experiments with crows and learning in particular. So in this next one, what they do is there's 3 tubes here, right? One of these tubes is actually a U-bend. Yeah, there are multiple versions of this same experiment. It's amazing. So there's one of these is actually a U, and the other one is just a tube that ends, okay? And this is food in the middle. So the only way he can get that food is to make the water level rise, and there are pebbles on each side. And you would think that a bird wouldn't be smart enough to figure out how to make the water level rise in this tube so that he can get the food out, but he absolutely figures it out because they're really, really bright. So you can watch him pick up the little pebble. He's like, I can't reach my food. First of all, the fact that he knows. Oh, there's Shannon. The fact that he knows that you can raise that water level, sorry, to get the food, it's impressive to begin with. Oh, who else is there? Oh no, it's just Shannon twice. Okay, sorry, there we go. Double Shannon. Ding dong. So that one didn't change anything. So he's like, am I really sure? Yep, that didn't help me out. And you can see, he looks at it. See how he turns his head? Because where are his eyes? Right, he's turning his head to get a better look. It looks like he's looking away, but if you're a person, he would be, but he's not. See how he looks like kind of sideways? He's clearly looking to see where it goes. So he's figured out where to put the pebbles in order to get the food. And there are tons and tons and tons of different versions of that experiment, and they're fun to watch. Some of them are longer, like much, much longer, and I wanted to include a short one for you. But if you look them up just for fun, it's pretty impressive what they've learned to do. Oop, there he goes again. Hello, dude. So then we have what we call complex behaviors. So complex behaviors are a combination of other behaviors kind of mashed together. So one would be innate behavior, and then we've got just sort of learning in general as a whole. So innate behavior is what we tend to call what? What's the other word for it? Do you know? What's innate mean?
Natural.
So what would that be? A natural behavior? An instinct, something you're born with, right?
Yeah.
Something you're born with. So innate behavior, sometimes called an instinct, is fully functional the first time it is performed. Yeah, look at that. You caught 2 of them in here. It doesn't catch the all capitalized things.
That sounds
Yeah.
like Arnold Schwarzenegger trying to say that word.
Yeah,
Yeah.
behavioral. Yeah, I'll fix that later. Thank you for pointing it out. So that's a good one, behavioral. So it's fully functional the first time it's performed. And you don't have to have, the animal doesn't have to have any previous experience with the behavior. It just knows how to do it. And as soon as it encounters that stimulus, it's going to respond absolutely instinctively. So it depends on patterns in the nervous system and the genes and the environment together. So I see a couple of instinctive behaviors going on here. What do you see in the picture? The baby's opening its mouth really wide. Now, does the baby know, well, if I open my mouth, it'll lead to my esophagus and the food will go to my stomach? No, but it knows to open its mouth if it wants food. Human babies will do the same thing. Human babies will gnaw on their hands. They'll turn their heads. There's all sorts of behaviors that they do that say that they want to eat. And actually human babies and newborns will turn their heads because they're looking for a breast. And generally that's how they get to it, is by turning their head sideways. So that's what they'll do. And that's instinctive for them. And the gnawing on their hands too.
Is grabbing a tree branch with claws an innate behavior?
Is who what?
Is grabbing a tree branch with claws an innate behavior?
Yeah, doing that.
Yeah.
Absolutely. Gripping is like if you take a baby, a human baby, and put your finger in its palm, they will do this, right? That's an instinctive thing as well. And so if you look here, first you've got the bird who knows it's hungry and its mouth is open. And then what's this?
A mother feeding?
Yeah. Did anybody teach her to do it? Did her mother say one day when you grow up, you're going to have baby birdies and you're going to have to eat and barf in their mouths? No, but she does that because that is instinctive to her. Now, have I told you about cowbirds? I think I may have told you about cowbirds.
That just like totally are terrible.
They make me mad. Yes.
Yeah.
So they're brood parasites. So a brood is your clutch of eggs, right? It's your clutch of eggs. That's your brood. You know, it's one laying of eggs, basically. Like my bluebirds that live out here, I usually have 2 broods each summer. So cowbirds are a local brood parasite, and you'll notice them. They come to my feeder too, and I'm like, because I just don't like them. but they're fairly big. They're not as big as a crow or a raven, but they're bigger than a robin. They're good size. They're black and they have a brown head. Comes right down to like where their collar would be, brown. What they do is they buzz around and find an open nest with eggs in it, lay one egg in it, move on to another nest with eggs in it, lay one egg in that until they finish laying eggs, and she'll lay her eggs in all these other nests. Then she's done. That's it. Yeah, think about it now. We talk about reproduction in animals, there is a cost to the animal, right? There's usually more cost to the female because she has to not only develop whatever offspring there is, but then at least those that develop internally, and then she has to feed it and all these other things. So if she can lay her egg and move on, she gets her genes to continue with very little investment on her part. That's good. That's good for her. But what happens is they tend to pick nests that are in great places like wren's nests. Wrens put their nests, they love to go up inside of porches and everywhere. We used to have in our old house, we had a covered front porch, and in the spring, I'd put 2 Boston ferns and hang them there. You know, pretty little ferns on the porch. Oh. And I had to take one down every year to water it because a wren had put her nest in it and I didn't want to squirt her nest. So I'd take it down, I'd water beside the nest and put it back up. Well, I did that one day and there was this giant egg in there that didn't look anything like the others, this big, big egg. So that's cowbird egg. But the difference between cowbird babies and like wren babies is the size of them. So that's also the size of their mouth. So what she's actually, her innate behavior, which is actually her instinct to do, is to feed the largest open mouth she sees. It's not even about this baby's mine and that baby's not mine. If you see a big open mouth, she sticks food in it. So the cowbird, huh?
There's also a brood parasite that will just kill the unborn.
Yeah. Mm-hmm.
eggs.
The cowbird babies eventually kill, they eventually kill the other babies in the nest, because what they do is first they steal most of the food, which causes them to starve. And then as they get bigger, they take up more space. And like James said, they tend to kick them out or knock them out because, hey, you're taking up my
I
space.
think some of them can eat them too.
Yeah, I don't know if cowbirds do, but some do. But so it's illegal in Georgia and in most states to take an egg out of a nest or disturb a nest in any way. But I had that cowbird that year and I was really, so I didn't want to like squash the egg or crush the egg because that's bad. You know, I don't want to hurt the little cowbird. It's not its fault that it's mother weighted in there. So I actually put it in a little heating area and I tried to nurture the little thing. I was going to hatch it separately from the wren babies, but it never hatched. So that was my bad. I shouldn't have taken it out, I guess. But there were 4 little wren babies in there and I couldn't bear to see 4 little eggs. I got to watch them grow when they hatched. I couldn't bear to see that cowbird just take all of their food. So yeah, so that's the instinct of the cowbird, and that's the instinct of the wren, is just to feed whatever's there. She doesn't consider where her babies are. So you guys know this instinctive behavior. You've seen it before. And this is again why animals such as turtles are a great example, why they have so many offspring, because you need them to survive in tough conditions when they're babies. So cute. You gotta love David Attenborough, yeah. Mm-hmm.
But for the young hatchlings, the trials of life have only just begun. Each new arrival will have to make a perilous dash to reach the ocean. Now they're on their own.
Yeah, they're so cute up close like that.
Inevitably, the tiny defenseless hatchlings attract scores of predators. Terns and herons patrol the beach.
Snatch. Yep.
And in the shallows, reef sharks lie in wait.
Yeah, he was. Run! Dude.
He turns around. Nope.
Yeah, can you imagine?
Bury himself in the sand.
Hurry.
Go, Craig.
Craig.
You made it.
Almost. Gotta get past the reef shark.
But enough will make it to the ocean.
He's so tiny. So that's why, remember, sea turtles will lay such huge clutches of eggs because they have to deal with the fact that there are so many predators coming after those babies because they've, for whatever reason, evolved to lay their babies in the sand on the beach. But that's the crazy thing. Those babies hatch and they go straight to the water. Now that's curious because there's not a magnetic pole, right, in that case. And like in the video with the possum lady that I shared last week that I adore, the possum lady, remember how she said the baby possums find their way into the pouch?
Yeah.
What'd she say it was? It's two things.
They like
Yeah, one was scent because the mom licks the trail, but the other was negative geotropism. So they use negative geotropism. And you remember what geotropism is, right? Like with plants,
Yeah.
what happens with plants?
Roots want to grow against, go with gravity.
Roots want to grow in a geotropic way and stems and stalks want to go in a negative geotropic way. So little baby possums and kangaroos too use negative geotropism to find their way up into the mother's pouch. Well, those turtles are not going up. They're not using like a clear magnetic field. Somehow, yeah, it has to do, I'm sure, with scent to some degree. And I don't know if we know all of the different ways that they're using to find their way to the ocean, but it's impressive when you see yeah, sometimes they use like if you're seeing like the overhead shots where you see all of them going at one time, there's a lot of them. That's a lot of little babies all going at one time. So imprinting, you guys said you were familiar with. So imprinting is really interesting, but it's when some animals, birds in particular, ducklings especially, will follow the first moving object they see, and they will follow it and follow it and follow it. Or the first biggest, most obvious, like they're all hatching at one time. Their brothers and sisters are there, but their mama, they see her and she moves, they move. That's why they walk like this and swim like this. I'm sure you see them across the street, right? They're all in a little line. And it's kind of hilarious when you look at it. They're so organized, but it's absolutely an instinctive behavior. But it's also something that, like, there is some bend in it. For example, if that baby is taken away early enough, it can imprint on other things, but they will imprint on humans. And this is my favorite. This is my favorite of duckling imprinting on human. I don't know where this man found this duck, but this duck is the cutest duck on the planet. And he follows this man everywhere. Watch when he runs, look. He's coming.
Where are you going?
Look at his little wings. That's just great. He's the cutest thing. I love him.
It's a noise that beat me.
Little chirp, 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 chirp. He's super cute, right? And he loves his human that he's following around, clearly. So when we talk about animals and their environments, we also talk about behavior that's related to cycles or seasons. Okay, so sometimes there are cycles that are daily, sometimes they're seasonal, sometimes they're annual. But you know that, you see ducks fly south in the winter, you see certain animals that hibernate, and then there are other animals that are nocturnal versus diurnal. So these are all things these are all instinctive or innate, but they're complex because they involve the environment plus their genes. So here you've got circadian rhythms and seasonal rhythms. So your circadian rhythms are your daily ones, right? These are your daily behavior cycles. So this is a what? You guys know what that is? What is that?
Cricket?
That's a cricket. Do you hear them during the day? Not usually, occasionally, but not usually, but you hear them at night. Yeah, you hear them at night. And how about those cicadas that we get? You hear them at night predominantly, right? So these critters are nocturnal critters. We're predominantly diurnal, but a lot of critters that we don't even really think about because we don't see them much, are really, really active at night. Have you ever had a cricket in your house before and you hear it, you can't find it? It's terrible. Sometimes you get one that'll hop in the house and you can hear it chirping, but you don't know where it is. And they chirp. They rub these back legs together. It's kind of crazy. That sound they make is just by rubbing their legs together. And it's a really loud sound. The what?
I thought it was on their wing.
I think it's somewhere right in this area. It's under their wings, I think. But it's wild that they can do that. So here's a circadian rhythm. we got some little mice here.
Imagine waking up at 3 a.m. to take a test. You might not perform at your best, right? But that's what lab animals do when their day and night cycles are not considered during scientific studies.
Stupid ass.
All living things have what is called a circadian rhythm, which is the body's natural cycle that tells you when it's time to go to bed or eat. For humans, our circadian rhythm is almost 24 hours when we are diurnal, which means we are more naturally active during the day. Mice that are commonly used in experiments, however, are nocturnal, and they are most active during nighttime.
There may be a 15 to 20% difference from daytime to nighttime. But because of convenience or whatever reason, when we do the experiments, we tend to do them during the day or during their rest period.
Dr. Nelson saw this problem and did an analysis of the 25 most cited papers in several behavioral areas, like book printing and memory. He found that 80% of the papers they surveyed did not mention anything related to the animal's circadian rhythm. There are several ways that scientists can take circadian rhythm into account. They can opt to only test nocturnal animals at night, or they can attempt to flip their light-dark cycle by keeping them in a dark room during the day or using dim red lights. But not reporting what method you use or not using any method at all can make it hard for another scientist to replicate the study.
It can happen to anybody. So you might be just busy. It may be inconvenient to flip your light dark cycle in the mouse rooms for a variety of reasons. You can't do good care sometimes when you have lights up during the day. So there's lots of reasons for it.
But Dr. Nelson said it's something scientists have to be reminded of. He recalled that even he made the mistake once, saying that his study had no effect on the animals he was testing.
We were so busy at the time that we tested them during the day. Right? And later on, my students sort of said, hey, it's all about timing and clocks, and let's test them during their night period when they're active. And when we did that, we saw a whopping effect.
Dr. Nelson's findings appear in Science Direct's Neuroscience and Biobehavioral Reviews Journal. WBOY, I'm Sheila Klein in Morgantown.
So that's University of West Virginia. And what's fascinating to me about that is that is a really recent video. Really recent video. But when I did my experiment on mice in 1998, I flipped. That was the first thing my professor said to me was, okay, well, if you're going to be studying a behavioral, impacts of a certain chemical on behavior, you're going to need to flip their day-night rhythms. And that's exactly what we did. I had a tiny little room, and we set up red lights and we set white lights on timers, and we blacked out all the windows, and we had white lights on timers that came on and stayed on all while I was asleep. And then when I did all my work in the dark red. It's fascinating to me that they have to tell people that, because they told me that back 25 years ago. They were like, hey, first thing you have to do is flip this. And I'm okay, no problem. Kind of weird that that's not been paid attention to, because it should be a really obvious thing. I mean, like they said, wake up and do tests at 3 a.m. You wouldn't do that, and that's exactly what that is if you don't flip their rhythms. And it's not hard to do. It takes some time. You gotta give it close to a month. So, I mean, I had a whole month to plan, and that's what I did in that month, was flipping. It was a big part of it. So another good example of a seasonal rhythm here. So seasonal rhythm, a good example would be, sit up, Alex, migration. So you've seen this, y'all have seen this, birds flying, right? And I love how geese tend to fly in this beautiful formation. But a lot of birds are going to find food and nesting sites south of where they live in the winter. So they're going to fly south. So what are some other seasonal rhythms that you guys can think of?
Hibernation.
Hibernation. Yeah, hibernation is a great one. What else?
Tree leaves.
Tree leaves. Yeah. I'm talking about for animals though. Like what seasonal rhythms?
Squirrel, not scavenging. Supply, what is it called?
Yeah, they stock up. Yeah, they store their food.
How
How about mating cycles? Mating cycles are really
Yeah.
seasonal, right? Very obviously seasonal. So that's something to consider. And some animals maybe not as much as others, but this is like one of my favorite little critters. He's so cute. So why do animals hibernate?
Why do animals hibernate? During the cold winter months, nothing seems more inviting than a warm day. But for some animals, hunkering down in a cozy den isn't just a matter of temporary comfort, it's necessary for survival. Hibernation is more than a deep sleep. It's a special state that certain animal species enter to help them weather long stretches of time when food is scarce. Hibernation triggers extreme metabolic changes. The animal's heart and breathing rates slow down, and its body temperature drops. Depending on the species, days or even weeks can pass without the animal waking up to drink, eat, or relieve itself. Certain species of fish, amphibians, birds, and reptiles experience dormant periods during cold winter months, but hibernation is generally associated with mammals, which have warm bodies that need lots of energy to keep them running. During the months when there's plenty of food, these mammals will eat and eat and eat, building up a special type of fat called brown fat. Brown fat reserves last them a long time because hibernating animals draw on them so slowly. During hibernation, their metabolisms would slow down to as little as 2% of their normal rate. Many types of mammals hibernate, including bats, rodents, bears, and even primates. 3 species of dwarf lemur in Madagascar and the pygmy slow loris in Vietnam. But one of the most extreme cases of hibernation is the Arctic ground squirrel. They sleep for weeks at a time for up to 8 months, and their body temperature during that time can drop as low as 27 degrees Fahrenheit. The science of hibernation, just one of life's little mysteries. If you'd like more life's little mysteries, check out these.
Stop talking. There.
Yeah.
So yeah, when you talk about hibernation, it's predominantly mammals that you're talking about. A lot of people want to say the frogs hibernate or the fish hibernate, and they don't really technically hibernate. Because, you know, if you're ectothermic, right, you don't need the same level of energy as an endotherm, because an endotherm is producing that energy, and part of that is their body temperature is, you know.
If your metabolism goes down to 2%, you need 1/50th the amount of food you normally do.
1/50th. Okay. Wow. That's like, yeah, nothing, pretty much.
Yeah.
Yeah. So they mentioned brown fat. So brown fat lasts a very long time. Interestingly, humans have brown fat as newborns and infants. And that is, if you think about it, evolutionarily, it makes sense. If there is scarce food, if the mother doesn't have enough food to produce enough milk for the baby or whatever the case may be, that baby can live off some brown fat reserves. We don't keep that through adulthood like we do as babies. But there was actually a story years ago about a couple that got stranded in their car in a snowstorm, and it was a long, long time. They were out there a long, long time, and they were very concerned about the baby, but the baby did way better than the parents. And later it was, you know, discussed that the baby had fat reserves that the parents don't have. So when we talk about social behaviors, we're talking about interactions between animals, and sometimes it's between animals of the same species, and sometimes it's different species. So we have courtship rituals, territorial behaviors, and cooperation. The territorial one is where you tend to see different species go at it with each other instead of being friendly, but they tend to fight. So what's this guy? Do we know what he is?
Peacock spider.
He is a peacock spider. I love him. So peacock spiders, this is the male peacock spider. He will dance. He performs a courtship dance to attract the ladies. And he will dance along a twig or whatever like this. And this is his abdomen, and he can flatten it out. He's got this beautiful color. He will flatten it out, and he will just wave it. And he will dance back and forth and wave it. And this is not something that he really has to learn to do, but he can, I guess he can along the way kind of learn to improve stuff or learn what the ladies like. Maybe I'll try this a little more to the left or to the right. You know, I don't know, but they don't have to be taught, you know, as babies. When you grow up, you're going to have to shake your butt so that the ladies pay attention. Nobody has to tell them that. They know that. So these are birds of paradise. Now there's a great one where they've put voiceover on this bird, and it's fabulous. It's absolutely, it's like that one with the prairie dog going, Ellen, Ellen. It's the same kind. I love those. I admit I'm a sucker for those. But this is cool because it has several different breeds of birds of paradise. Yeah, this one's I think this one's a little different. It's longer. But these guys are all doing their different courtship dances, and some of them are really, really impressive.
In the Great Island of New Guinea, there are 42 different species of birds of paradise, each more bizarre than the last.
Get him with his head. Watch the head. That looks like a Muppet to me. I'm sorry. Looks like something from the Dark Crystal.
Yeah, it does.
Forest is so rich that nourishing food can be gathered very quickly. That leaves the male six-toed bird having a nice time to concentrate on other matters, like tidying up his display.
He's making the area pretty. I mean, look at that. There's a stick here. No, no, no. This is my stage. He's wiping it down. That's crazy.
Excuse me, could you move out of the way?
Yep. Ah, here's my stage. Yeah, I'm good. I'm good. Yeah. Look at that head shake. What a funny little thing to do. Yeah. Trying to impress the girls. Woohoo, look at me. I mean, that's, there we go.
Very impressive.
No one's watching. Poor guy.
The superb bird of paradise calls to attract a female.
Beautiful sound. Yeah.
And he has more work. But what does he have to do to really impress?
So this is fine. So he called her and she came, and now he has to impress her. Look at this.
It looks like a spirited away character.
Isn't that weird?
This is fun.
It is.
What is that noise?
She retired.
He's doing it.
I think when your knees crunch that much and doing squats.
Look at her looking at him like, I don't know.
Deflated when even the best are
And she's not impressed. Poor guy. Yeah, totally rejected. So you got territorial behaviors too. So here you've got these moose. Clearly they're banging heads.
Really good, don't you think?
Huh?
So they're just eating grass.
Eating grass, yeah, right next to each other. So many animals occupy a specific area or territory that they defend against competitors. Animals may use threatened behaviors or aggression to defend their territories, and they can also use aggression when they compete for resources, and those resources also include mates. So sometimes you'll see male animals especially compete for an area that is, you know, this is my area, and all the ladies that pass into it are my ladies, thank you very much. And then you'll see them fight for mates. I'm sure you've seen videos of deer and, you know, mountain goat or whatever, bang heads, rams, they'll bang heads. Now, bucks in this area will do that. They will fight each other to gain the attention of a mate, but sometimes they'll fight so hard that they actually crack their skulls. And if they do that, then they can get like bacteria inside their skull that affects their brain. Bless you. And so sometimes if you ever see a buck just like wandering around in circles, looking aimless, that may be what happened to him. Yeah, they just literally wander around in circles because they don't have they're not thinking clearly at all. Their mind is kind of addled at that point. And that's usually an animal that has to be put down because there's no way to fix them at that point.
So many deer that comes through my backyard.
Oh yeah, us too.
My backyard is just like
Yeah.
a ravine, basically.
Yeah.
And they all just come up and they're just like chilling. And then
Yep.
one day there was this buck who just came up, looked around, and just shot right back down.
Wow,
He just
really?
went,
That's funny. We get all of them through here. Yep. So this involves, this is territorial defense, but this is interspecies. So this is not just like moose versus moose.
A new threat has arrived on the riverbank.
Wish they would balance out volumes.
The roving pride of lions, undernourished,
They're
and
always
longing for territory. It's the dry season, a daily battle for survival. And like the hippos, they rely on both land and water. 12 lions of various ages. It's a lot of mouths to feed. To satisfy 12 bellies efficiently, they need to set their sights on big prey. They're hungry and thirsty. Temperatures are soaring over 100 degrees, and they can smell water. To get a drink, they need to breach the riverbank. But this is hippo country, and they must respect the bull's territory. Hippos are fiercely territorial and notoriously aggressive
Yeah.
when defending their patch. Even lions give them a wide berth.
You're like, no, thank you. We don't need it. We don't really need it.
Didn't want to say that.
Yeah, JK, hey.
Never mind.
But the proud male bows to no one.
He's big cheese, so he don't care.
A single lion is no match for an enraged hippo 10 times his weight. The water line marks the boundary, and to cross it, he'd better be primed for battle.
The Cincinnati Zoo a couple years ago had the baby hippo named Fiona that everybody was like, oh, she's so cute and she's adorable. The hippos are rough, man. They are very, very aggressive animals, big, big mouths, super heavy, and they can swim crazy fast too. So yeah, they are very territorial, like I said, easily would take out that lion, no problem at all. Just crush him, really. Poor lion. Yeah. Yeah, he's like, I don't care if you're king of the jungle, you're in my water. So social behavior, cooperation. So we talk about cooperation. So some animals form a society or group that interacts closely and often cooperatively. The theory that helping a relative survive increases the chance of transmitting one's own genes is called kin selection. So if you're trying to keep your family versus somebody else's family, that's kin selection. The most complex animal societies are those formed by ants and bees and wasps, animals like that. And all animals in a society cooperate closely to perform complex tasks like nest construction. So, you know, primates form little societies too. There's, you know, with gorillas, you have like your silverback gorilla and he's your alpha male. And then you got some other males, and then you got your females and the babies, and they all have, there's hierarchy, there's definite hierarchy. But bees, that's super complex, the way that they run their society, and everybody's role is very defined. And if you've seen the Bee movie, it's like all one big joke about it, but it's basically what it's pretty accurate, really.
So good.
Why do you want to do anything else? This is all you want to do, yeah.
Never did that time back.
Yeah, I mean it's
You know, I did.
oh no, I like that. It's a cute movie.
There were some
It is a
parts
great
that
movie.
were funny, but
But when you think about it, even kin selection is even built into our instinctive behavior. It's even built like deeply, deeply into our psyche, like way into your reptilian brain. Because if you had, you know, a person tied to the train track A and a person tied to train track B, and the one tied to train track A was your relative, and the one tied to train track B was somebody you didn't know, and two trains were coming at the exact same time, you would untie A every time. You would do it.
What if you don't like the person there?
It doesn't matter. You would still likely take your kin over somebody that's not your kin.
Are we
Unless it was a
required
fake.
to untie?
Yeah,
one
I
if
mean,
that
that's the
person is
thing,
just like
isn't
a
that-
post Get ran over.
It's an interesting
Or it
thought.
could be this talented that you could get a poke.
It's an interesting thought. There are all kinds of the train and the tracks, like moral and ethical questions. Like you have one person over here, like you can save, oh, that's a good one. You've got a train coming and there's a switch, right? And if you let them stay on the track, it's gonna run over your family member. But if you move the lever, it's the only thing you can do, then it goes off the track and kills everybody on the train. What do you do? Like, those are interesting moral and ethical questions. But what were you gonna say, Piper?
Which family member?
That's true. Which family member does?
Yes,
Yeah.
I need to know which family member this is.
Well, and when you're talking about kin selection and your innate desire to pass on your genes, people tend to be more protective of their children than their parents. And there's reasons for that, and this would be one of them. So these ants here do some pretty fascinating stuff. Way
I'm
more.
telling Maggie, let her die before me.
Well, she would expect that. Go away. I am so tired of all these things.
That's okay, she would say this thing. She said,
When it comes to feeding the colony, ant ingenuity and teamwork has been taken to another level in Argentina. Although there appears to be plenty of food for these leaf-cutting ants, the lush fields are actually deceptive, because these leaves are naturally protected with cellulose, which ants are incapable of digesting. To combat this, the colony form a production line. Worker ants use their mandibles to cut up the leaves.
You good?
Others then transport the harvest back to the colony. Where underground, more ants chew the leaves to create a thick mash. This mash is then used as a compost to cultivate a particular type of fungus that the ants can eat. They've been doing this for 50 million years.
Did it just freeze on me? Hello.
Making them
Guess we get to stare at that ant for a minute.
oldest farmers on the planet.
Not much left there anyway. That's bizarre. There we go. And I love this picture here. This one, right? No, is it not there? I thought y'all had it. Oh, I had it in the other group. The ants made they'll make a little body bridge to connect themselves. It's so cool.
Have you ever seen Ant-Man?
Yeah. But they'll make a little body bridge so other ants can walk by. So last thing we get to
Some
is
of the Ant-Man you listen to. Yeah.
listen, the last thing we get to is communication. So this is passing information from one individual to another. So you can do this visually, chemically, or using sound. And sometimes it can involve a language, which is what we're talking about right before lab starts. So this cat's communicating clearly. What's the cat communicating?
Go away.
Yeah.
I'll bite your face off.
Yeah. So this is a stressed cat. So when animals do this, dogs will do this too, not quite the same way. They don't raise their backs up, but they will raise their hackles. They'll have their hair on their back stand up. And that's when they're stressed. And they do it because it makes them look bigger and more threatening. So I've heard from people that do a lot of camping and hiking, we have a lot of black bears in this area, and black bears are not aggressive compared to other bears. And they're not big compared to other bears, but to us, they're big and aggressive, right? Compared to humans. But don't ever trust me or test me on this, but I've heard from people who are avid hikers and campers that if you make yourself bigger, like if a black bear comes to you and you go, make yourself really big, chances are it'll turn and walk away.
Be big and make noise.
I don't know. Have you heard that in Scouts? Is that accurate?
Yeah, be big and make noise.
Be big and make noise. Yeah. Whereas with some other kinds of bear, they say ball up. If that bear's coming at you, just ball up. You don't have much of a chance. So like Kodiaks and grizzlies and things like that were different.
Yeah. Don't ever see a grizzly and you're probably safe.
This is true. I don't ever want to see a grizzly. So yeah, so animals will do this to make themselves bigger. Think about a pufferfish. A pufferfish does the same thing to make itself look bigger. And also it makes it harder for it to get eaten, right? Because now it's much bigger than whatever was looking at it.
It makes it easier to poison things.
Yes, this is true. So a lot of animals will do this. They'll get bigger and look more threatening. And you can see humans will do this too. Like humans that are getting ready to fight, you'll see them just see people stand up really tall, put their shoulders back really big. It's all an aggressive posture, right? So a beta, like my dude here, like my dude Bunsen here. That's Bunsen. So yeah, if you show a male beta a mirror, he thinks it's another male beta because they're not very bright. And they will attempt to at least look aggressive, if not bang into the glass and fight it. So watch him puff up. See the instant puff up? Fins got all big. And they'll do that because they're like, look at me, I'm big, I'm gonna fight you. See how big he got? And then when he gives up on it, moves away. When he sees it again, you'll watch him get all big again. Like he's like, oh yeah, you're back. So you're back. Back again, huh? See the pups, the gill flaps in front come forward, everything. It's actually a fun thing to do with betas. It stresses them out if you do it too much, but it's an interesting thing to watch them react because they do it every time. So if you do it too much, they'll get stressed because it's constant, you know. So another example of communication that's chemical, obviously we had that in lab today. Another great example is when animals spray to mark their territory. Cats in particular are famous for this, but dogs do it too. Dogs pee. You know, when your dog pees when you're taking him for a walk, he's not really peeing. It's just like a little drip here, a little drip there. And you're like, dude, you really don't have to pee. Not really peeing, he's marking, right? He's marking his territory. This is my walk. This is my route. That's my lamppost. That's my fire hydrant. You know, that's what they're doing. And they're doing it to let other dogs know, don't come near my stuff. Or if another dog has peed there before them, well, then they have to pee on top of it because no, I was here, it's mine, you know, and that's what they do. But cats will spray all kinds of things. They'll spray furniture and all kinds of stuff in your house because they're in the house. You can actually see this cheetah spraying. Like if you look close, you can actually see it spray, which is crazy. So they leave pheromones or chemical marks behind. Some animals leave scent posts to mark their territory. So a scent post is something that's marked by an animal with its scent. Scent posts set the boundaries of an animal's territory. So if you are an animal such as this one, you may walk basically what's the boundary of your territory and mark things along the way so that other critters coming that way know they're coming into your space. These lemurs, man. Yeah, this is funny.
One of the females is on heat. It's her choice and she's unpredictable.
I didn't write it.
A chance for fatherhood is up for grabs. Fights quickly break out. The object of their affection just sits and waits. Whilst the squabbles continue, one sneaky young male sees an opportunity to make his move.
He's like, oh, they're fighting, but I'm here.
He hopes to win her heart by more subtle means.
Watch, this is wild.
With an air of nonchalance, he settles down and begins to smear scent onto his tail from glands on his wrists.
It's like air
Yeah,
The
your
perfume
turn.
he wafts over her will tell her a lot about what he has to offer as a potential partner. Might offer something that the other males don't.
I don't
He may
know.
not be the strongest fighter, but the very latest science suggests that his scent might contain clues to a different strength. His ability to fight illness and parasites, which he could pass on to her offspring.
I'm waving the tail, waving the tail, waving the tail. Smell it, smell me. She's like, get away, get, I'm just sitting here enjoying the sun.
She's still not convinced. Maybe she should wait for the outcome of the fight. The battle continues unresolved. So she leads him off to somewhere quiet. His sneaky seduction has finally won her over, and they head off for some undercover love.
So she cared more about how he smelled than how good he could fight, right? So another example of communication is sound, and you know whales are good at this. The cool thing about whales is they use their three main types of sounds, which are their clicks, whistles, and then their pulsed calls. And the cool thing is you can have a pod of whales with a little community, a family of whales, and that speak a dialect, and then another pod of the same species that speak a different dialect. So their basic language is the same, but their dialect is different. So that's kind of like words we use in the South versus words they use in the North. Yeah, use guys. Yeah, that kind of stuff. Yeah. So they actually have their own dialect within their group. And that's partly how they distinguish their group from another group. which is really interesting because they can actually tell, are you foreign to me? This guy, though,
What is that?
this is a great example of communication through sound. I love this dude.
But sometimes more unexpected sounds grab our attention. Like this desert rainfall. Squeaking viral sensation.
It sounds like an angry squeak.
11 million hits and counting. It sounds like a dog toy. But actually, this is the sonorous war cry
Dog would love to play with that.
of a very angry foe.
He's actually saying.
I wouldn't be terrified.
Ferocious.
Like you heard about the end. Like,
I love the little sound they make. There's
I want to see a voiceover.
right, right. So your answers, these are pretty obvious, so I'll leave them up for you guys in the slideshow. You can always look. So we talked about Kanzi before, right beforehand for lab, and about how Kanzi learned to use all the little,
That's how big the nipples are supposed to be.
Yeah, I think so. He's a male, so he's good size. He's sitting in a little tub. They're cute, isn't he? He's a little chunky guy. He's a chunky boy. He's a chunky boy. You want him to be a little smaller? I know. He's like, oh, that was that big. Because I like him, but I don't like him that big.
Look at him enjoying his life.
He's sitting there in that tub. He's chilling. So anyway, so they taught him how to use the lexicograms on the soundboard. And then eventually he picked up ASL from watching videos, which is pretty amazing. And then they found later that he was making those sounds, with the apparatus he had, but he couldn't replicate human language, but he was doing his best to replicate it. So we saw this part. There was another, I thought I put it in here. I thought I put it in here, a different video. But we already saw that. So I do want to show you guys your test, your upcoming test. In order to study for your test, you're going to want to go to your resources folder, the one that looks like this. As soon as you go here, it's right there with everybody's stuff. And you've got your test study topics here. Oh, what do you know? They're all in here. Won't this be handy when you get to a final exam? Yeah, no, it might be. But if you go here to Unit 7, I put them all in basically one slideshow, and I gave you the option to do it as PDFs, as a PowerPoint, or as just looking through the JPEGs, because there's a lot of them. This is a wide variety of stuff. But what you need to do for this test, and I'll put this in the weekly email because the younger kids aren't here to hear it, but this test is going to be a lot less like fill in the blank. It's not going to be what kind of animal has this, and that trait, or a definition, and then you put a word to it. There are going to be some matching like that, but a lot of it's going to be thinking. It'll be very much thinking. And I'll tell you, you will be given a large JPEG full of animals of different kinds. And then you're going to have to sort those animals based on what kind they are. Like you're going to have to be able to, I'll give you a description and you're going to have to go, it's that one or it's this one. And sometimes it'll say things like, I'm in the order or whatever, and you're going to have to know what that order is. But it's not going to be, it should be obvious. Like I'm not going to ask you the genus or order of an animal that is, a cardinal. If there's an animal that is the only one in its order, then I might say the only member of my order, which animal am I? And that should be obvious. If you look back through these things, all the things that I have in here, all these slides, it'll be there for you. So I took all the stuff that we had done and I put them all into a series of slides like this. I moved some of this information out of the original slideshows and moved them into here for you, so it was a little more condensed. But if you are familiar with these characteristics and the types of organisms that belong in these phylums or classes or groups, depending on how we looked at them, you'll be good to go. If you remember that sponges, what's the thing about sponges that's different from every other animal?
They're
They have no symmetry. That's right. That's your big standout for sponges, right? They have no symmetry. So if you can remember that, that's a big thing. Remember that they're filter feeders. They're sessile, right? They don't move. And then what's the big thing about cnidarians? You remember?
Do they have to be cylindrically symmetrical? What is that called?
They have They have radial symmetry.
Yeah. that's what it's
And
called.
yeah, and then these are the types of animals within that group. And these are the main ones that have radial symmetry aside from echinoderms, right? Most everybody else is going to have bilateral symmetry. So if you can remember that they have the radial symmetry and that they're includes these types of animals, jellies, hydras, sea anemones, coral. And then you should be pretty familiar with these because we had them in lab. You know, your platyhelminths, they're flatworms and they're jelly-like, right?
And they're also really good at getting killed by us.
Getting divided up. These are your overarching characteristics of mollusca. These are your big ones. So bilateral symmetry. Yeah, I love this little, he's so cute. Thing is really neat. So these are the main phylum of mollusca. Bless you. This is phylum mollusca, and these are the main classes that we looked at. So we had our gastropods, and remember, they're things like your snails, right? They have a, bless you. They've got the head, mantle, foot, and then this hump of organs enclosed in, usually in a shell. Your bivalves are the guys that can close up, right? And this is where you find things like oysters with the pretty little pearl there.
Damn.
And I will tell you, some of these pictures here are going to be the same pictures and some of them are not. So you may have a different type of gastropod or a different type of bivalve or a different type of cephalopod. So
What cephalopod is it?
so this is a cuttlefish, yeah.
Oh,
And they're so cool. I love cuttlefish. They're like the best. They're really, really cool.
don't you eat them?
You can eat squid. I guess people eat cuttlefish, but I wouldn't.
Can you eat cuttlefish?
Yeah, yeah. People do stuff with the ink. They put the ink in, and octopus ink too. Sometimes they put it in like noodles and stuff to make those black noodles. I don't know. I don't know if that's. Yeah, it's just a little much for me. But yeah, so these guys you got to remember are gonna have. They're gonna have heads, right? They're gonna have some kind of head, and they're gonna have, you know, bilateral symmetry. Even the octopus has bilateral symmetry, and that they. The big thing about them is that radula, that they almost all have that radula, but and a head. That's your big stuff. So arthropods, these were the big category, the big characteristics of all arthropods. But when you get down into these guys, so we just looked at him today, right? And we know he's a spider. And this is the group that includes spiders. So harvestman, remember that is what you probably call a daddy long legs. And that it's not technically a spider because a spider is one of this subphyla. And same thing as mites, ticks, and scorpions. And then you get hexapods. These are your insects, right? All your insects. So remember they've got their 2 pairs of antenna, mandibles, 3 pairs of legs, those types of things. Your crustaceans, you've got most of these are marine, but they're not all marine. What's a good example of a terrestrial one we talked about in class?
Roly-poly.
There you go. Is a terrestrial crustacean. That's right. And then Myriapoda is easy to remember because it says many feet, basically, right? So those are those are going to be your centipedes and millipedes. Your overarching characteristics of Echinodermata. And then these were the big categories that we studied with echinoderms. So this actually has the word in it pretty much for star, right? You can see it in there. So, you know, an aster is a flower, looks like a star. There you go. Same word being used again and again. But you've also got your sea sand dollars, or what we call them, sea urchins, those kinds of things. And then these brittle stars. What are you laughing at?
The second class. Do you know how to spell it?
Echino, yeah, it's echino. And it looks like echinoidea. Yeah, isn't it? It's terrible. Yeah. They all have oidea. All of them have something and then oidea. And we had our brittle stars. These guys are the little dudes that hang out on the bottom. They're sessile and they don't move around. And then you have your fun sea cucumbers, right? Cucumbers. Yeah, they're really cool though. So when we get into our phylum Chordata and our subphylum Vertebrata, these are your main types of vertebrates, right? But hugely important to remember why we use chordate instead of vertebrate as a general categorization. Because the sharks, skates, and rays. Yeah, if I asked you to give an example of an animal that is the reason for that rule. Yeah, anything like that. A shark, skate, and a ray. You got to watch for them because they, remember, are chordates but not vertebrates. Now, when we get into the lamprey and the hagfish and stuff, we get into agnathans, they kind of have their own weird, like I said, their own fuzzy corner over here. And the reason they have their own fuzzy corner is because your hagfish don't have any sort of spinal stuff going on, but your lampreys have more like a cartilaginous type of spine, but it's not, none of it's as evolved as a shark. So they're not quite chondrichthyes, and they have no jaws, and one of them has more of a spine than the other. So they are kind of in this fuzzy little corner over here, but you guys wrote about them, so you should know enough about them to know where they go. And then here's your sharks and your rays over here, and skates are pretty much like rays. So your osteichthyes are your bony fish, and that's easy to remember because ichthyes is always fish, right? And osteo is, or osteo or ostea or anything like that is bone, so it's easy. So those are your osteichthyes. Amphibia, your general characteristics. How many chambers are in an amphibian's heart?
3.
3, right?
Did we ever cut open a frog heart?
We had the heart. Some of you cut it open, so some of you didn't. And so far, every animal we've talked about is going to be ectothermic, right? Even these guys, especially these guys. These guys are the ones with the complex life cycle, right? Metamorphosis, you all know forever. These are your main types of your amphibians. You've got your salamanders and newts over here, your frogs and toads here, and then these weird guys over there, right? So
those weird snake-like.
Yeah, Caecilians are strange looking. Yeah. So this is the other word to remember, tetrapod. Remember that a tetrapod is a 4-limbed thing. Yeah.
It says toads instead of toads.
Oh, it sure does. Oh, good catch. No, you guys have caught like 3 today.
Frogs and toads.
Frogs and toads. Fun times.
Dr. Seuss.
So yes, so frogs, toads, and apoda. This one's easy to remember because all of these animals from this point on tend to be tetrapods, except, oh, this guy,
Which
apoda,
means without feet.
without feet, no feet. So that's easy to remember. So your tetrapods have 4 limbs, and that's pretty much everything except maybe snakes, but everything from here on. So when you get into your reptiles, like here's your reptiles, they're vertebrates, of course. They're still ectotherms. They've got eggs. What kind of eggs do reptiles have that are different from
Hard.
amphibian?
Leathery.
Leathery. Yep. What else is in them? Same thing that chicken eggs have. Yep. So what do we call those? Yeah. What do we call that?
Albumin.
Amniotic egg, right? Amniotic egg. So an amniotic egg.
Is it called albumin in all eggs or chicken eggs?
I think in all. I think in all. Yeah, I think it would be. Yeah. So these are animals that have the egg with the complex structures inside and fluids. So they've got albumin and a yolk and whatnot to help nourish the babies, unlike little frog eggs that just kind of lay there and they just have jelly in them, right? These are your main groups of your reptiles that we studied. Squamata, Testudine, this crazy guy here. I really think somebody should write about tuataras. And then your crocodilia. So when you see, you
And in
know,
the background of the crocodile or alligator, there's houses.
yes, there are. That's Florida. You know,
Yeah.
Florida.
Florida.
Florida man sees giant alligator in his backyard.
And
Mhm.
that's no wrestle it.
Yeah, not fun. So,
It's always Florida.
You ever watch
mhm.
that show where there's
My
just a
mother's.
bunch
I'm
of
freezing my
guys
mother out of the house.
on a
As I turn the-
reality show, and they're just captured gators and took them back to their like reserve and like.
So remember, these are ones you do want to remember. You want to remember Squamata, Testudine, Crocodilia. These are things you should definitely remember. So these are your turtles, tortoises, and your lizards and snakes. So they're both in the same category, whether or not they've got legs. And then this funky dude here, funky dude, cute little thing. They're so cute. Their little faces. Doesn't somebody want to do a thing on that? Anyway, your defining characteristics of birds. Make sure that you've just kind of gotten a good sense for them. A lot of your test is about understanding the different characteristics between different groups of animals and then being able to categorize them properly. Because I truly believe that if you can understand how things fit together, it's sort of like a liberal arts concept, but you can see how these animals fit together within the whole ecosystem or within the whole phylogeny of how we got to where we are. It's helpful because it puts things within a perspective. So that's kind of the angle I'm coming at from this. I mean, we could spend forever talking about bird bones, and we don't need to do that. As long as you understand that they're hollow, then you're good. So physics of flight we went over. Just know that they do that. Now, I'm obviously not going to make you remember these orders of birds because this is ridiculous. But if you know the general qualities and characteristics of birds, and there was a bird for you to group with that list of characteristics and qualities, you should be able to figure it out, right? Now, it may say things like ectotherm or endotherm, and you're going to have to look at your list of animals and go, okay, let me take out all the ones that are ectotherms, and because I'm looking for an endotherm, or vice versa. So the graphic that goes with the test, you cannot open. It says so at the very beginning. Don't look at this until you're ready to take the test, because I don't want you to study it ahead of time. You need to move along while you're doing it. But I do say at the very beginning of the test in the notes, I do recommend you print it. When you sit down and you get ready to take your test, print that out so that you can write on it, because that you can cross out ones you've used, and you can't do that if you have to keep going back and looking at the picture on the screen. It's much easier to just do it next to you. So all these dudes, different kinds of birds, are really fun. Goodness, that would be crazy to memorize. So remember the defining characteristics of mammals. These are important, right? Some are here, but you get the basic idea. They've got that nice evolved neocortex. Remember, you have a neocortex, right? It's the part of your brain that allows you to do all your seeing and hearing and have great supersensory stuff. And then when it comes to brains, we also have a more developed cerebrum, remember? Now, if you look here, like platypus, there's only one family of platypuses. So that's kind of interesting to remember, right? And you've got your monotremes here and your theriforms. So those are your two main groups of your mammals. I do love this guy though. This guy and this guy. Look at the face. Doesn't he look like he just woke up from a nap? He's like, why are you waking me up?
Is that an echidna?
Yeah, he's a cute echidna. So remember that the point of a negative feedback loop, it's about limiting a system, right? So if you're like, my mother was just freezing, so I had to turn the air conditioning off. I turned the air conditioning on because I was hot. So now she just texted and said, if your kids are mostly gone, can you turn the air up? Down there, it's even colder because she's down in the lower level of the house, and it can be like 5 or 6 degrees colder in her house than it is up here. So it's the same thing, your body temperature increases, you start to sweat, then you get cool, then you get too cold, then you start to shiver, and then that makes more heat, and then you get too hot, and the same sort of thing. And remember when we had this graphic that moved, it was about, your overall panic level increases with these little crazy cows, and it just keeps going. And then this is a graphic for a negative feedback loop that doesn't involve a person, basically how thermostats work. Do know your body planes, yes, but mostly know these different directional terms where bodies are concerned. The posterior, anterior, dorsal, ventral, inferior, superior. These are important to know. Anytime you do any biology class from here on out, and most of you will probably have to do something else at least once in college, you're going to have to know that stuff. And it's important to know if you want to read your own medical records, because this is what's in it. They put these terms in your medical records, so be sure that you know what they mean. And then response. We talked about responses today, stimulus response, how animals respond, different nervous systems. You got these guys with the nerve nets versus us with nerve systems, central nervous system. When we really get into our nervous system, we have some fun little labs for that. We're not going to do the thing like when we terrified Aniston, though. That was really fun. Everybody that was with me when we did middle school biology remembers that. We were taking her, thank you. We were taking her pulse and counting her respirations, I think it was, both of them. And we got her to like super relax in the chair. She didn't know what was going on. And then after she'd been quiet for like 30 seconds, her eyes were closed. She was looking so relaxed. And we'd taken her pulse, and then everybody at the same time screamed. She came out of the chair 18 inches easily, just boom. Screamed. She was almost crying. Yeah, she was almost crying. It scared her so much, but it was great because we were like, take her pulse now. Everybody's taking it now. Of course, her heart's pounding. So yeah, different ways we detect stimuli, obviously our different sensory organs. Hey, Boober, what you doing? Go say hi to James. Know these. What'd you say? Oh, what, this? He's learning. He's learning things. I'm sorry. He's very busy. Yeah, he's learning. I like him. I like it.
Tesla's down 2 points. What the heck?
Yeah, man. He's checking his stocks. That's right. So learn your different types of learning and conditioning. I'm glad it makes you laugh. You remember this page then. That's important. I try to do that. Remember this page too. This was from 2 separate pages in your previous slideshow. Especially know your endoderm, mesoderm, ectoderm, and know this bit about how you go from this morula stage here to the blastula stage. When we talked about blastula, it's this nice little hollow ball. That's important because that's your first real developmental stage. Respiration, sometimes you got breathing through the skin, sometimes you've got breathing with systems, sometimes you got gills.
Yes, pause.
Right? What, Ozzy? Okay. Yes. So all that, remember all that. And that your aquatic invertebrates, they have their way of getting oxygen. And then these guys have their little gills and you do it like this. Just kind of remember there's gills, there's lungs. And then you've got actual systems for vertebrates that involve, you know, diaphragms pulling down, decreasing pressure. You get air coming through trachea, through bronchi, through bronchioles, through down all the way into your lungs. Circulatory system. Know that you've got closed and open circulatory systems. What's an example of an animal with an open circulatory system?
Jellies.
Not really. How about insects? Remember? And they have the fluid in them is called hemolymph, and it just sort of flows around within their body. It doesn't go through, it's not a closed system, whereas with us, it's closed, right? It stays within a loop and it goes through, you know, one tube to another tube. The only time it hops tubes is really like red in here or red in here, and it hops at basically like a cellular level. It doesn't float around much. And there were positives and negatives to that. So you've got gastrovascular. That's when you're talking about your jellies and stuff. And that's this sort of deal. And your open kind of looks like this, and your closed looks like that. So remember also that with your open system, this is an open system, you've got advantages and disadvantages to it. And with your closed, you've got different advantages, obviously, but this is your mammalian heart. Now, how many chambers are in a mammalian heart? 4, right? Remember that. There they are. 2, 3, 3, 4. Ta-ta-da, 4. Excretion, what are we trying to get rid of mostly in this case? We're getting rid of waste, but what chemical in particular? Ammonia. Yeah, ammonia turns in, yeah, that all turns into uric acid, but it's ammonia that we're trying to get rid of in general. And that is what forms urea. So we're trying to get rid of ammonia, and that's all things that metabolize basically animals. So even fish, like I cleaned him last night because his water was gross. His water is gross because he's squirting ammonia out of his skin all day long because that's what he does. So remember that ammonia is what you're trying to get rid of. That's why, like people that have cats and litter boxes and then don't do a good job with them. That's why their houses smell like ammonia, because there's a lot of ammonia in cat pee. Sometimes more, depending on what you feed them. So here's your amniotic egg. We talked about what it contains. There it is right there. Just remember what they are. So those are the big things. And it's, I've given 90 minutes for this test rather than 60 because I expect you to go back and forth. You're gonna have to do a lot of looking when it comes to the question that involves that big graphic. You're gonna have to look at it, read. It's gonna be like a matching thing. Actually, I think yours is matching. Yeah, I think yours is matching. Yeah, but you're gonna have to basically match the description being given with one of those creatures. And there's only gonna be one that works. So you're probably going to want to look through it, make your decisions, and then put your answers in, because you probably don't want to change them too much. It'd get really confusing, I think, if you did that. So do that and you'll be good to go. And next week we start all the fun. And next week you don't have to turn in any homework from me for a very long time. Remember, a very long time, which is great because I have things to do this spring. Oh, and I mentioned it in the email that the dance that we do every year is coming up in April. Do come if you can come. I know you've got tickets purchased. Your mom's got tickets purchased. Yeah, your mom purchased for, I think, you and Katie and Claire.
We're
Think-
triple booked that night, so I have no clue what's gonna.
It's gonna be, well, Katie's thing's the next day too.
Yeah,
So Katie's
that's
baccalaureate.
that's not a big deal though. 'cause
Yeah.
We're not doing it at our house.
Yeah.
What was the deadline?
Yeah. So anyway, it's the 22nd of April, 22nd. Yeah, Friday the 22nd. So what we do is, we haven't been able to do it for the last 2 years because COVID stinks, but we will, we book out the clubhouse at the front of the neighborhood, and I decorate it, and we have food. We have a big buffet table full of food and snacks and whatever, and
That's nice.
it's nice. People come and, swipe food, and we have a little photo corner where people take pictures, and we borrow a sound system from a friend of ours who has one that has flashy lights and stuff. And I put flashy lights all over, so we have little spinny lights and colors. It's fun. And we basically take requests all night. Jason sits there and is like, what do you want? And people put things on the list, and as long as they're not ridiculous. Yeah, we play them. My favorite video from all of those is your dad
Oh,
and his dad sitting at the table. Was it Humpty Dance?
No. Henry did.
No, Henry's video is good, but then Nate and Cole, Nate and Jason sitting there, two dads at the table rapping 90s music together. It was hilarious. It was great. So
Was it Lose Yourself?
no, I think it was the Humpty Dance. I think it was it was way back, and they were both singing it, and they were throwing it at each other. I got it on my phone. I have no idea. But anyway, we will let Shannon go. We'll see you next week. Bye, Shannon. You'll be good to go.
Shannon.
Shannon.